Let's have another example falling under case 2, the ambiguous case. How many solutions are there if A equals 15, B equals 20, and A equals 27 degrees? Now, to restate this problem, how many triangles can be formed if side A equals 15, side B equals 20, and angle A is 27 degrees? So here, we're given two sides and an angle opposite one of the sides. So SSA. Therefore, this falls under case 2, the ambiguous case. So we have A equals 15, B equals 20, and angle A equals 27. So these are our given. Now let us analyze the given. So since A equals 27 degrees, therefore angle A is an acute angle. Side A is less than side B because 15 is less than 20. Now A is greater than B sine A, since 15 is greater than 20 sine 27 degrees. And 15 is greater than 9.08. So, looking at the SSA possibilities table, which is found on page 16 of your learning package 1, under row 1, column 2, we can say that the problem has two solutions. In other words, two triangles can be formed. Now, since two triangles are expected to be formed here, then we will have to solve for the parts of those two triangles. Since two triangles are expected to be formed here, then we will have to solve for the parts of those two triangles. Triangle 1 will have parts, the original given parts, which are side A, side B, and angle A, plus the parts that we need to solve, and those are side C, angle B, and angle C. For triangle 2, its parts will be, of course, the original given parts, which are side A, side B, and angle A, plus the missing parts, which we will have to solve. The missing parts of triangle 2 are side C prime, angle B prime, and angle C prime. Now note that side A, side B, and angle A will automatically be parts of the second triangle because they are the original given values. Since they are the given values, they automatically form part of the two triangles, and we will only need to solve for the other missing parts. Now, let us verify the answer by showing a solution. So, we will now be finding all the parts of the two triangles. So, let's first solve for angle B. Now, since sides A and B as well as angle A are known, then we can use the formula sine B over B equals sine A over A. So, by substitution, we will have sine B over 20 equals sine 27 degrees over 15. By cross multiplication, we will get 15 sine B equals 20 sine 27 degrees. Dividing both sides by 15 will give us sine B equals 20 sine 27 degrees over 15. Therefore, sine B will be equal to 0.6053, correct to 4 decimal places. So, since sine B equals 0.6053, therefore B, angle B, will be equal to sine inverse 0.6053, which is 37 degrees, 15 minutes, and 2 seconds. Now, rounded to the nearest degree, rounded to the nearest minute, this will be 37 degrees and 15 minutes. So now we know the values for side A, side B, angle A, and angle B. Let us now solve for the supplement of B, and let's call it B prime. Now, angle B plus angle B prime will be equal to 180 degrees. Since the sine of an angle and its supplement are equal. So, B prime will be equal to 180 degrees minus B. So, B prime equals 180 degrees minus 37 degrees 15 minutes, which will be equal to 142 degrees 45 minutes. So now we have the values for side A, side B, angle A, angle B, and angle B prime. Let us now solve for angle C. So by the angle sum of a triangle, angles A plus B plus C will be equal to 180 degrees. So angle C will be equal to 180 degrees minus A minus B. So by substitution, we will get this. And therefore, angle C will be equal to 115 degrees and 45 minutes. So now we have side A, side B, angle A, angle B prime, and angle C. Let us now solve for angle C prime. So remember, angle C prime is now part of the second triangle. So the three angles of the second triangle are angle A, angle B prime, and angle C prime. So by the angle sum of a triangle, we will have angle A plus angle B prime plus angle C prime equals 180 degrees. Transposing A and B prime to the other side, we will have C equals 180 degrees minus A minus B prime. So C prime will be equal to this by substitution, giving us the value 10 degrees 15 minutes. Now, since this value for angle C prime is positive, therefore this angle will be accepted. So again, since C prime is a positive angle, it is therefore accepted. So we now have the values for side A, side B, angle A, angle B prime, angle C, and angle C prime. Now, before solving for side C and side C prime, let us first check whether the sum of the three angles is equal to 180 degrees. Now, using the concept that the sum of all the angles of a triangle is 180 degrees, or the angle sum of a triangle, we have A plus B plus C, or angle A plus angle B plus angle C equals 180 degrees. Substitute the values, and we will get 180 degrees equals 180 degrees. So indeed, the sum of the three angles is 180 degrees. Now, let's check also whether the sum of the three angles in the second triangle is 180 degrees. So, the angles of the second triangle are angle A, angle B prime, and angle C prime. So by substitution, we will have this. So substitute the values for angle A, angle B prime, and angle C prime, which is this. And we will get 180 degrees equals 180 degrees. So therefore, check the sum of the three angles of the second triangle is also 180 degrees. So therefore, we can now proceed with solving for side C. Now, since side A and angle A as well as angle C are known, then we can use this proportion. Sine C over C equals sine A over A. By substitution, we will have this. And by cross multiplication, we will get C sine 27 degrees equals 15 sine 115 degrees 45 minutes. Since we need to solve for C, therefore we need to cancel this sine 27 degrees. And how do we do that? We do that by dividing both sides by sine 27 degrees, which will give us this. So using your calculators, you will get C equals 29.75937514, or C is approximately 29.76, correct up to 2 decimal places. So this is now the value for side C. Now let's now solve for side C prime. So to solve for side C prime, since side A, and angle C prime are known, therefore we will have to use this proportion. This is sine C prime, this is supposed to be C prime, over C prime equals sine A over A. By substitution, we will have sine 10 degrees 15 minutes over C prime equals sine 27 degrees over 15. By cross multiplication, we will get C prime sine 27 degrees equals 15 sine 10 degrees 15 minutes. Since we are solving for C prime, therefore we need to cancel sine 27 degrees. And to do that, we will have to divide both sides by sine 27 degrees to get C prime equals 15 sine 10 degrees 15 minutes over sine 27 degrees. So we will get C prime equals 5.87931,506, or C prime is approximately equal to 5.88, correct up to 2 decimal places. So since we were able to find all the missing parts of the two triangles, okay, therefore we can now conclude that there are indeed two solutions for this problem. In other words, two triangles can be formed based on our given values. Now at this point, you may now answer activity 1.7, Law of Sines, SSA or the ambiguous case, on pages 17 to 18 of your learning package 1. Then transfer your answer to the LMS once you're done reviewing your answers. Now let's have an example of the application of this law of sines. So we have this problem. A person has a kite out on a 1,650 feet of string at an angle of 80 degrees with the ground. An observer notes that the angle formed by the kite and the flyer is 105 degrees. Now, how far is the kite from the observer? So this is our illustration for this problem. Again, it will help if you make your diagram or illustration when you are given word problems or application problems. So here's the person with the kite. Here is the kite. Okay. So the string is 1,650 feet long. It's this one. Okay. So this is the angle formed by the string with the ground. So 80 degrees. Okay. The angle formed by the kite and the flyer is 105 degrees. This is the observer. Question is, how far is the kite from the observer? So this is the kite, this is the observer, and we're going to solve for this. So what's the distance from the kite to the observer? Now to solve for side D, okay, remember the sine of an angle over its opposite side is equal to the sine of the other angle over its opposite side. Therefore, we will use this formula or this proportion. D, side D, over sine 80 degrees, this is the opposite angle of side D, 80 degrees, equals 1,650 over sine 105 degrees. So this is 1,650, the side. Opposite that side is this 105 degree angle. By cross multiplication, we will get d sine 105 degrees equals 1,650 sine 80 degrees. Now, dividing both sides by sine 105 degrees, we will get d equals 1,650 times sine 80 degrees all over sine 105 degrees, and we will get this value. D equals 1,682.25. This is now rounded off correct to the nearest hundredths or correct to 2 decimal places. So therefore, we can conclude that the kite is 1,682.25 feet away from the observer. Now, this ends our discussion for the topic on law of sines. By this time, you may now answer activity 1.8, Solve Me, on page 19 of your learning package 1, and as well as activity 1.12, Am I Possible, on page 23 of your learning package 1 as well. And after answering, you may now transfer your answer to the LMS once you're done reviewing your answers.